Hi.
I guess I'm
I'd
good.
like to introduce my friend John Whittle from the University of Lancaster. First met him last year at ICSE in San Francisco, and excited that he's here to talk about us with how model-driven software development, who's doing it, how, and why. Without further ado, here's John.
Great, thank you. Before I start, just so I know my audience, how many people here know roughly what I mean by model-driven development? Okay, not everybody. This is going to be a challenge. By the end of this talk, you will know what I mean by model-driven development. I'm not going to spend a lot of time explaining what model-driven development is. I will try to give a quick introduction to what it is for those of you that haven't heard it before. But before I do anything, I want to do a little exercise with you, and that is I want to ask you to cast your mind back to the year 2001 AD. Welcome. Cast your mind back to the year 2001 AD, 12 years ago. In the year 2001 AD, Wikipedia was invented. Seems very much part of our daily life now, especially if you're a student, but it's actually not that old. It's only 12 years ago. In 2001, we finally got to learn if the predictions made by the film 2001: A Space Odyssey were actually going to come true, because 2001 came and it went, and HAL did not take over the world. And back in 2001, the organization in which we now sit, Carnegie Mellon University, Silicon Valley, did not exist. I believe it was 2002 that it was created. I hope that's right. But there was something else that was going on in 2001 in the software engineering world. And that was that in 2001, the Object Management Group, now this, for those that don't know, the Object Management Group is an organization that produces a lot of standards for software engineering, things like the Unified Modeling Language, if you've ever heard of that. They came out with a new standard that kind of got people really excited in the software engineering world. And it was called model-driven architecture. Now, this wasn't really a new idea. What it basically said was that, the vision was that instead of having people write code, they could write high-level designs, and then they could generate the code automatically from those high-level designs. So they could write UML models for those people that know UML, and they could generate code from UML. Didn't have to be UML, though. They could create their own design languages or their own modeling languages that matched the domain that they worked in. So if they worked in, space systems, for example, they could come up with modeling languages that had the concepts of space systems built in, and then they could magically generate code from those high-level designs. So this was the vision, and it was the OMG trying to standardize this so that everybody would use it, and they called it model-driven architecture. It wasn't a new idea, really. It had gone under lots of different names. So, more generally, it's been called model-driven development. In academic world, we tend to call it model-driven engineering. Model-based software development has been called model-based design. Lots of different names. So basically the same idea, that you try to raise the level of abstraction at which you build software so that you can generate the code from high-level designs. And you basically cut out a lot of the grunt work that you have to do as a software developer. Okay? And as I said, in 2001, this standard was introduced, and it created a lot of excitement. So people in all branches of software engineering started becoming model-based. So there was, in the testing world, people started getting excited about model-based testing. So this is perhaps what a typical tester might look like. People doing maintenance, they became model-driven. They're like, oh, let's use models to control the way that we actually maintain our software systems. And this is what a typical kind of maintainer might look like. People doing integration said, oh, we can take multiple systems that weren't designed to work together, and we put models in the middle, and everything will work really well. And this is what a typical integrator might look like. And then there was even two worlds that, had been kind of so far apart. That was the kind of plan-driven, model-driven development world, and then this kind of agile world of, no process, let's do everything agile. There was even something invented called agile modeling, and that's what a typical kind of agile modeler might look like. And then even here, at CMU Silicon Valley, and certainly at NASA Ames next door, people were doing model-driven development. So you might ask, well, what does a kind of typical CMU Silicon Valley look like? And the answer is, well, they might look something like this. or at least that's what Todd told me when he invited me to come and give this talk. So there was a lot of excitement. So what is model-driven development? For those that don't know, the best 101 way to describe it is that a modeling language is a high-level language. It's a language you use for design. It's not Java, it's not C, it's not C#. It's higher than that, something like UML. And there are three different ways. Martin Fowler coined this way of thinking, that you can use modeling languages. You can do what most people do, and that is what they call sketch modeling. And this is where you've got a bunch of kind of designers around a whiteboard, and they're drawing boxes and arrows, and they're using it to kind of come up with their design as a way to kind of communicate, as a way to kind of understand each other. And that's what we call sketch modeling, and that's what most people do. I'm sure you've all done it here. Then you've got people that do a little bit more formal things than that, and they come up with models that are precise enough that they describe the system that you're building in enough detail that you could hand it to a team of software developers and they could actually implement it. So this is what they call blueprint modeling. The analogy here is if you're building, the new span on the Bay Bridge, you would have a blueprint that would say, this is the design, these are the dynamics of it, but then you would give it to a construction team who would actually hammer in the nails and actually make the thing happen. So that's blueprint modeling. And there's fewer people that do that. Now, what we mean by model-driven development is where you're actually using the modeling language as a programming language. Okay, so you're not producing that blueprint model and then giving it to a team of software developers to implement it for you. You're producing that blueprint model and then you're giving it to a machine that generates the implementation for you. So that's the vision, And what this talk really is about is, does that vision actually exist in practice? Depends on if
we need to use the microphones or this.
I'll repeat the question. So the question was, what would you call the other one where you actually give the model to a team of developers to implement it? It's probably blueprint. If it's well enough specified, it would be blueprint. It may, it lies somewhere between sketch and blueprint, depending on how well specified your model is. If it's really detailed enough that you really can hand it to someone and they can implement it without asking any questions, it's blueprint. If they need to come and talk to you and say, well, what did you really mean by this? Then it's probably more towards the sketch. But the point I'm trying to make is that model-driven development is one method for developing software that has actually spawned a huge number of a huge industry in terms of tools. IBM has produced lots of tools like rational tools, Rose Real-Time. There's tools like Simulink that all try to enact this vision of modeling as a programming language, that is model-driven development, where you have a high-level description of your design, and then you just press a button, and the code magically kind of comes out. Okay, so that's the vision. As we'll see, the visions are not always implemented in real time. So back to 2001 AD. Lots of excitement about model-driven development. Why? Well, because it was going to solve lots of problems of software development. It was going to solve the productivity problem. We were suddenly going to become super productive as software engineers because we didn't need to write code anymore. We could just create models at a high level, then press a button and we'd get the code out. It would solve the maintainability problem because if the requirements change, all you needed to do was to change the model, regenerate everything, and everything would work wonderfully and perfectly. We would be in utopia. Portability problem, technologies change, a new programming language is introduced, a new kind of web services description language is introduced. This causes problems for software companies because they have to transition to that new technology. With model-driven development, this wouldn't be an issue anymore because they'd have the design and they could just plug in a new generator that would generate that new form of technology, right? And interoperability systems would be able to talk to each other in ways that they'd never been able to talk to each other before because models would be used as kind of interlingua between these different technologies. So all was well with the world. Or was it? There were certain naysayers that said, hold on a minute, we've seen this before. This idea of modeling has been tried before. It was tried in the 1970s, something called case tools were tried. It didn't work. And this idea that you can just come up with designs and then generate code automatically from that is nonsense. The code is the thing. And so there's been a lot of controversy over the years about whether model-driven development is actually a practical software development technique or not. We're now in the year 2013 AD, and so it's a good time, 12 years after that first initial specification of model-driven architecture, it's It's a good time to ask the question, who was right? Was it these proponents of model-driven development that said, this is the way to develop software? Or was it those detractors, those people that said, no, 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 it's about writing the code, So which was right? And that's what I'm going to talk about in this talk. What I'm actually going to talk about is a project that we've been running since 2009 in Lancaster University called EAMDE, which stands for the Empirical Assessment of Model-Driven Engineering. And basically what we wanted to do, we wanted to answer this question of who was right. And we wanted to answer it by actually talking to industry. So what we did, we went out into industry and we talked to and we studied as many companies as we could find that were actually doing model-driven development on real projects. And we tried to document what was it that made some of these companies hugely successful with model-driven development, and what was it that made some of these companies fail and not use the technology anymore? Because this is what's happened in the industry. Some companies have picked it up and it's been really successful. Some companies have tried it and it just didn't work for them. So what was it? What were the factors that lead some companies to succeed and some companies to fail? And in particular, we were interested in not just technical factors. And the reason is that whenever you try to introduce a new technology, a lot of what determines success or failure is going to be more about the social or the organizational factors. How is the company organized? How is it structured? Does that support this new way of thinking? What are the people like in that organization? And so what I'll talk to you a little bit about is some of the discoveries that we found. First of all, just in terms of some observations about how people are actually using model-driven development in practice. Then some lessons about which of these social, organizational, technical factors that lead to success or failure. And then I'll finish with some tips. So if you're a practitioner, I don't know if anyone here is a practitioner, but if you're a practitioner thinking of adopting model-driven development, what are the kind of things that you should be aware of to introduce this technology? Okay, so what was our methodology? I don't want to dwell too much on the methodology, but it was a three-pronged methodology. The first thing we did was a survey. So we created a survey with about 35 different questions asking people about how they used model-driven development. And we got a lot more responses than we thought we would, actually. We got about 450 responses to that. Detailed information about how people use model-driven development. Now, surveys are good. They give you numbers. Everybody likes numbers. But what they don't give you is the rationale behind those numbers. They don't give you the qualitative data. So in parallel with that survey, we conducted a series of semi-structured interviews with software professionals who were actually using model-driven development. And we went into about 17 different companies and we interviewed about 22 different people from about 10 different industrial sectors, all of which had experience on the ground of using model-driven development. And we recorded those interviews, we transcribed them, we got a huge amount of data, about 150,000 words of data, which covered people's experiences of trying to apply this technology in practice. Now, interviews are good, they're better than surveys, but they're not perfect because you only get to hear what people tell you and what they remember. And sometimes you actually have to go and watch people work to kind of really learn about what it is that they're doing. And so we also did a very small number of studies, just a couple, where we actually watched what people were doing, and we used techniques from social science like ethnography to actually study how people use model-driven development in practice. Some disclaimers, though, before I go any further. What EAMD is not, it's deliberately not an attempt to quantify the penetration of MDD in the industry. I will not give you numbers like, 50% of people use MDD. That wasn't the aim of this study. That would be a different study. I think MDD is a niche thing anyway, so it wouldn't really make sense. It's also not just a study on UML. So UML is probably the most well-known modeling language. It's a standard modeling language. It's not the only one by any means. And one of the themes that will come out in the talk is that people that create their own modeling languages, that is domain-specific languages tailored to a particular domain, are often more successful than those that try to use UML. And thirdly, this is not an attempt to kind of evangelize or promote MDD. I'm not here selling a product or promoting a company or promoting the technology. Although I come from the modeling community academically, that's my heritage. We were actually interested more in failures, really, because it's from failures that you actually learn about what's really going on rather than successes. So, okay, what did we discover? Well, the very first thing we discovered was that there are people out there doing model-driven development. Now that may come as a shock to some people, but there are plenty of people out there who are actually succeeding with model-driven development. And the ways in which they are using model-driven development are incredibly diverse. So you definitely have people that are trying to implement the grand vision. And to give you an example of that, in North America, there is a huge effort going on right now in the banking sector to try and use models to kind of formalize software development for the entire banking sector. So the kind of thing that they're doing is they're kind of documenting, what are the fundamental concepts of banking, transactions, overdrafts, loans, things like this. And they're coming up with a standard model that documents all these things. And then the idea is that, any company producing financial software will use that standard document as a way to kind of generate applications. And this is a huge effort, it's got multiple banking companies involved in it. It's got hundreds of software developers involved in it. It's taking very, very many years trying to standardize an entire domain and then, come up with a way to kind of quickly and rapidly develop applications from that domain. So that's very much in line with the kind of the grand visionary form of model-driven development. But at the other extreme, what you'll see is people apply model-driven development in very, very, very small ways. So there might just be, a small team of developers within a particular company that are using model-driven development to kind of automate some of their processes. So they may have found, for example, that they're developing the same kind of software again and again, and rather than keep repeating the development of that software, they create their own little mini domain-specific modeling language and their own little mini code generator from that domain-specific modeling language, so that it kind of makes them more efficient, but it's not a grand kind of vision kind of thing. So this kind of application, they talk about the kind of thing that's on this quote, that they're developing modeling languages not for embedded applications, or not for even mobile embedded, or even not for a particular brand of mobile embedded, but for a very small product family that's only used within that company, and that modeling language is only useful to them. They typically might develop this modeling language in as little as a couple of weeks, and then they just write a very quick and dirty generator for it, and they generate code from that language. And that language may not have a very long lifetime. It may only last for a few months and then be kind of discontinued. So you've got everything. You've got, the big visionary kind of stuff, and you've got the kind of mini MDD, and you've got everything in between, essentially. So that's what we've seen out there in terms of, how people are actually using this technology. I'll give you 4 kind of high-level discoveries, and then I'll talk in a bit more detail about some aspects. And these are 4 discoveries that we've made about model-driven development. So the first discovery about model-driven development is that a lot of the success of model-driven development is actually hidden. Okay, people don't know about it. So what do I mean by this? Well, if you think of model-driven development as this visionary thing, this model-driven architecture, and then you go and look for that, you won't find a lot of people doing that. You won't find a lot of that kind of banking style, very grand, very visionary kind of stuff going on. What you will find is a lot of people kind of doing the little stuff, the mini MDD. And they often don't even call it model-driven development. They might call it something else. Or they might not even realize that they're doing model-driven development. But they are generating their own code from their own modeling languages. And one of the reasons why a lot of this is hidden is that there appears to be in the industry a greater preponderance of domain-specific languages than I expected. So domain-specific languages are languages that people create for themselves for their own application. They're not meant to be standard for any kind of software. They work for telecommunications or space systems or banking, or in fact they work for a subset of banking or a subset of telecoms or a subset of space systems. But they're geared towards a very specific job, a very specific tool for a very specific job. And this is just some data from our survey, and this kind of illustrates this point a little bit, because we asked people, which modeling languages do you use? And although, as expected, UML is used very commonly, about more than 80% of the people said that they actually used UML. What I find surprising about this figure is that there's a lot of people saying that they use DSLs, domain-specific languages. These were either domain-specific languages that were sold to them by a company for their particular domain, or they were DSLs that actually they developed in-house themselves. So, almost 40% of the companies that we talked to said that they were actually developing their own DSLs in-house. And this is quite, at least for somebody in the modeling community, this is quite a surprising result, because it's always the talk about UML, 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 UML. And they're not using UML, they're using the things that they've developed themselves. And if you dig into that a little bit further and you look at the data that we got from kind of our interviews, the qualitative data, it turns out that those companies that are successful generally tend to write their own code generators for very specific tasks. In contrast, those companies that try to take the big, expensive, off-the-shelf tools, like the IBM tools, they struggle a lot. The classic case is the organization that, a manager comes in one day and says, all right, everybody, we're going to model from now on, and we're going to use this tool to model. And they try to kind of convert, hundreds of kind of C programmers overnight into modelers, and it typically doesn't work very well. Where it works is where companies, are using this in a very ad hoc, very agile way, and I do mean agile, in a very agile way. And they, as I said, they develop their own code generators for very specific tasks that might not have much of a lifetime. So the generation of whole systems using this model-driven development is actually not very widespread. What you typically see is companies just developing a very small piece of their software using this kind of model-driven development. The second discovery is that code generation is a bit of a red herring. So I've mentioned the word code generation probably 100 times so far in this talk. And most people, if you say model-driven development, they think of code generation. They think exactly what I've described, which is high-level models. You generate code from those high-level models. Now, it's interesting that it turns out that if you talk to industry, the main reason that people like model-driven development is not because of the code generation. Okay? And I'll give you an example of this. So this is a company that they were working in embedded systems, and they are very successful with model-driven development, and they use code generators, but they don't use code generators for deployed code. What they do is they use code generators to prototype their functional requirements. So they do some kind of rapid prototyping using code generators to come up with, to get the functional requirements right. But what they said is that they would never actually use the code generator in the actual final system, because they've got all these difficult non-functional requirements that they have to deal with, and it's just cheaper for them to get experienced programmers to kind of code that by hand. So it's an interesting case that, it's a company that liked MDD, but the main reason that they used MDD was not for code generation. If it was just for code generation, then they would be using it for the deployed code, right? But they're not using it for the deployed code. We've also seen some interesting cases where code generation can actually cause more problems than it solves. So this is an example, and this is where we get into kind of organizational factors. This was a company that had different units to the company, and there was one software unit within the company that started to use code generators, and they were really happy with it because they were generating all this code. But as with a lot of code generators, the code that you get out is often inefficient, it's often not very well commented or structured, it's quite difficult to understand. But they didn't care about this because they were getting all this code. But then they sent it to the part of the organization that was doing the hardware and actually had to deploy this onto hardware units, onto CPUs. And what they found was that the inefficiency caused them a lot of problems. And because the organization was kind of broken, instead of going back to the software guys and saying, give us more efficient code, what they did was they just went out and bought more resource. They bought more CPUs. So it's an interesting case where you've got benefits from code generation in one part of the organization, and you've got losses in another part of the organization. And we've seen this in other ways as well. So we talked to a large certification authority in the UK that certifies all the code that goes into government information systems in the UK. So companies come to them and they say, hey, we want to put this code into a government information system according to our contract, please certify it. And they do it. And they have processes for doing this. But they're increasingly getting requests for people for them to certify auto-generated code. And so there's one story where a company came to them and said, hey, we're using this very well-known, very expensive tool to, I won't mention which one it is, to auto-generate the code. Please certify it for us. And the certification authority looked at it, and it was not very readable. They couldn't really see what was going on. And it didn't match their processes for certifying stuff. So they kind of scratched their heads and they went back to the client and they said, well, look, our processes don't support this kind of auto-generated code, but we'll do it. We'll find a way to do it. It's just going to cost you 8 times the amount that we would normally charge. Now, interestingly, at this point, the client actually said, that's fine, go ahead, we'll pay the money, because they'd already gone so far down that path of investing in model-driven development technology that it was too late to go back. But the moral of the story is that once again, you can see that they thought they were getting savings by using code generation, but they ended up with losses in another part of the organization. So it's an organizational factor. You have to be very careful about gaining in one part and losing in another part. And the moral about all of this is don't obsess about productivity. So if you actually look at some of the numbers about productivity increases that you get from model-driven development, and these are not our numbers, these are numbers from the literature, you'll see a very wide range. So you'll see there's been studies where they say that actually model-driven development has caused a loss in productivity of up to 30%. There have been other studies where they've said we've got an 800% gain in productivity. And you'll see everything in between. But generally speaking, the kind of number that comes up again and again and again is a 20 to 30% gain in productivity that you get from model-driven development. Now, if you think about that number for a minute, 20 to 30% is actually not very much. Would you really introduce a completely new technology for a 20% productivity gain? Probably not, because you've got all kinds of organizational processes. Wow, I thought I was going to have to do a dance. This was one of the tricks that the organizers pull on in guest speakers, I guess. Get them to dance to music halfway through and spice things up a bit. Yeah, 20% is not a lot if you have to change your organization, introduce new processes. You have to introduce new training programs to kind of train people on this weird thing called model-driven development. So it's unlikely that if you're getting a 20% gain from code generation, that's the main reason that people are using model-driven development. So if the main benefit of MDD is not code generation, what is it? There are companies that like model-driven development, but they're not doing it principally for the code generation capability. So why are they doing it? Well, it turns out that the real benefits of model-driven development are holistic, by which I mean that the real benefits of MDD come in the fact that you improve the quality of the software, you improve the quality of your architecture, and you improve the element of reuse that you're actually able to achieve. And it's an interesting fact that if you talk to these companies, what they often say is that, MDD on its own is not the answer to anything. For any given benefit of MDD, you can always find some other technology that does it better. But where MDD works really well is if you combine it with an effort to improve reuse, if you combine it with an effort to kind of document your architecture properly. One company we talked to did exactly that. When they started, they introduced MDD at the same time as introducing a reuse group, and they found that the two really worked really well together. And then there's the question, well, I'm claiming that MDD leads to a better architecture. Why might it lead to a better architecture? Well, we're not completely sure of this answer, but one of the reasons might be that, if you follow kind of a traditional kind of top-down development process, where you define your architecture before you do a lot of the coding, it's quite hard to come up with a good architecture, because you don't really know enough about the system that you're going to build yet. But the companies that are doing model-driven development, they often follow a kind of bottom-up approach. They often have been developing the same kind of software again and again for multiple clients, and they start to realize that things can be reused and that things can be abstracted. And so from the bottom up, they build their generators. And therefore, they're building the architecture from the bottom up. And so it helps them to actually define that architecture. It's quite a difficult thing to define an architecture. It's really a tricky thing to do. But model-driven development it may force you to define a good architecture, because it forces you to think about how can I generate code from this architecture. And if you have to think about how can I generate code from this architecture, you have to write your architecture in a precise enough way that you can actually generate the code from that architecture. Okay? And a good example of this is a company that we talked to that had lots of little generators that were all working together. They were little DSLs based on XML in this case. And they were generating about 70% of their system using code generators. But what they kind of discovered was that they were doing an interesting form of separation of concerns. So separation of concerns is a good software engineering principle, but they were doing it a little bit differently. And that is that, because they were using model-driven development, they were forced to make decisions about, which bit of the model can I generate code for, and which bit of the model is just too complex that I need my fancy programmers to do it, okay? And this allowed them to kind of separate out their architecture very naturally into those bits that were generatable and those bits were non-generatable, or those bits, in other words, which were simple and those bits which were complex. So they got a better understanding of their overall architecture because they knew where the simple stuff was, and they knew where the complex stuff was, and where they had to really think harder about it. And that's something that they might not necessarily have got using other methods. Okay, now the fourth discovery is that model-driven development must enable new things, not just speed up old things. So people from NASA here will remember the kind of faster, cheaper, better days. I won't go into that. But model-driven development is often sold in those terms. It's often sold that, it'll increase your productivity. It will enable you to do things faster. But as we've seen, if faster means 20 to 30% faster, no one's going to adopt MDD to be that little bit faster. It doesn't make business sense. Where it does make business sense is where it allows you to fundamentally change the nature of your business and allows you to be more competitive. A good example of this is a printer company that we talked to that started doing MDD about 10 years ago. And back, well, actually probably 15 years ago now, but back 15 years ago, the amount of software that was going into printers with device drivers and so forth was increasing rapidly. And so they had to hire software engineers to build this software, and they were doing it all in-house. And very quickly, software became a problem within the organization. It was always late. It was always overrunning the budgets. And so very quickly, when the employees of the company went for a beer in the local brew pub, it was the software engineers that found themselves in a corner of the room. Nobody really wanted to talk to them because they were holding the business back, right? What happened with model-driven development, though, over that 10 to 15-year period, is that they were able to automate a lot of the software stuff. It was relatively simple stuff, and software was no longer a bottleneck. Okay, so the software engineer could drink beer with their colleagues, finally. Okay, so what MDD had actually done, it had changed their business fundamentally. They'd become a software company, but it allowed them to go back to being a printer company. So it really allowed, it wasn't just that it allowed them to build the software quicker, it really changed their business and allowed them to be more competitive in the market. So those are the kind of four kind of high-level things that I wanted to tell you about. We've discovered a lot. I mean, I said at the beginning this was, the focus here was not so much on technical stuff, but on organizational stuff and social stuff. So what are the social and organizational factors of adopting a technology like MDD? What have we discovered? And I'll just run you through a few quick things. I'll run you through a few quick things that we loosely call the psychology of MDD, although there's no real formal psychological foundation to any of this. Software architects love model-driven development. Okay, they love it, generally speaking. And all of this is generalizing for the purposes of a talk. But they love MDD. Why? Because it's about control. What do architects do? Well, they're very clever people that come up with architectural constraints that other engineers have to follow. And if they come up with those architectural constraints and they write them down and then they try to get the software engineers to follow it, the software engineers have minds of their own and they might go off and do other things. But if they come up with those architectural constraints and they encode them in a code generator, no one can touch them, So the beautiful work that these architects do is encoded within a model-driven development process. And so the architects get a lot more control of what's going on. And so they quite like this thing called model-driven development. On the flip side, the code guru hates model-driven development. So this is the guy that everybody, the real smart programmer guy that when there's a particularly thorny programming problem, that's who everybody comes to in the organization. They say, solve this. And he does it, or she does it. He or she doesn't tend to like model-driven development because they lose control. People don't come to them anymore for that thorny programming issue because it's already been solved and it's already been encoded in the code generator in the model-driven development process. So they don't like it. Neither does the hobbyist developer. So the hobbyist developer is the kind of guy or gal that has a 9-to-5 job as a software engineer, But at the end of the day, it likes technology and goes home and reads books about that new programming language, and then they want to come back to work the next day and they want to try things out with that new programming language within their actual working process. They don't like model-driven development either, because again, a lot of the creativity has been taken away from them. A lot of the creativity has actually been encoded within the code generation process, and so they feel like they're losing creativity, they're losing control. Now, the obvious answer to that is to make these people creative modelers rather than creative programmers, but that's not as easy as it might sound. It's bad news for offshoring. So we talked to a lot of companies that told us that development work that they'd previously sent overseas, they were now able to bring back onshore. And this was because the kind of stuff that they typically sent overseas was the simple stuff. They'd draw up a specification and send it to China or send it to India or send it to Malaysia or wherever, and then they'd get something back. But it was exactly that kind of simple stuff that model-driven development was good for, and so they were able to kind of bypass that altogether, and they got much more control over it, and they brought that back onshore. Middle managers are usually the bottleneck. This is no big surprise. If you're going to introduce model-driven development, you need at least two things. You need a champion, someone who's going to really push for this technology. You also need the developers on the ground to be in favor of it. But even if you've got all of that stuff, you could still run into problems in that kind of middle management area. Now, middle managers are typically very risk averse because they're given very limited budgets and they're told that they have to deliver on time. And so any new technology that risks pushing that budget or pushing that schedule is going to cause them problems. So if you're going to introduce model-driven development, then you might want to give extra resources to your middle managers. We've talked about the code guru. Well, what does the MDD guru look like? Well, it seems to be the case that the MDD guru has to have two things. They have to be both a developer and a domain expert. So, if you're developing a domain-specific modeling language for a particular domain, you need to both understand your domain, but you also need to understand how to write code generators that produce optimized code and so forth. Now, it can work if you've got a small team that has a bunch of domain experts and a bunch of kind of compiler guys and bring them together. But if you do that, there'll probably be a lot of kind of miscommunications between them. It will work better if you've got those two skill sets within the same brain. And so if you have people, the MDD gurus, who are both good at kind of writing code generators, but they really understand that domain. They really thoroughly understand the domain they're working in. This is an interesting one. So model-driven development seems to work best in companies that are not in the software business. Now, what do I mean by this? Well, to give you an example, we talked to a very large German consultancy, software house, and they had hundreds of different clients, each working in different domains, telecoms, aviation, automotive, whatever. And in each of those different domains for each client, they were using model-driven development very, very effectively. But they then went on to tell us that they would never use model-driven development to develop the kind of software that they developed in-house for themselves. They just wouldn't do it. So it was good for their clients, but they didn't want to do it themselves. Okay? So it seems to suggest that this kind of modeling approach is better for very specific domains, not for kind of general-purpose software. And part of the reason for this is that people working in specific domains, domain experts, they already model. If you go into an automotive company, you'll see people drawing models using PowerPoint or something else that talk about the kind of the ECUs in the car and how they interact with each other, and they'll be doing models in a way that general purpose software engineers don't. And so they already have an established way to design, and so it's a small step from there to get them to design a little bit more formally so that you can actually generate code from it. Okay, so that's some of the lessons that we've learned. I want to kind of finish off, I suppose, by just giving you some data from the survey that we ran. So a lot of the stuff I've presented so far has been based on the qualitative interviews that we ran. But people usually like numbers in talks, so I like to give them some numbers. So what would 449 MDD practitioners say about modeling? Well, who are these people, first of all? Well, if you look at our sample, again, they're quite diverse. So they range from people who were just doing initial explorations with MDD, to people who had started kind of doing prototyping with MDD, to people who were on their first major project, to about a third of them would actually had many, many years of experience on many, many different projects applying MDD in anger. Okay, so a quite diverse range of experience. And the first thing we found was that people tend to use multiple modeling languages. They don't use a single modeling language. So it's not the case that, if you're using UML, you only use UML. It's not the case that if you're using DSLs, you only use DSLs. 62% of our respondents that were using DSLs also use UML. Of the people that did use a single language, UML was definitely the most popular. But even UML was used in combination with just about every other modeling language that you can think of, SysML, whatever it is. You think of a modeling language, there are people out there using that modeling language in combination with UML. So it's not a kind of, there's no single standard wonderful solution to all of this. Okay. What we really tried to do in this questionnaire was unravel what we call points of contention about MDD. So for any given benefit of MDD, you can usually find somebody that will find a drawback of that thing. Okay, so if you take code generation, for example, you talk to one person and they'll say, well, code generation is good because it, automates the software development coding process, therefore it increases your productivity. But then you talk to another person and they'll say, well, actually code generation is pretty bad because you then get this code that's unreadable and you have to integrate it into your legacy system, and that takes a lot of work. So the question is, this is a seesaw, with code generation, for example, do the benefits outweigh the drawbacks? And there's lots of things like that with MDD, and we wanted to just get a sense of, do the benefits of a particular feature of MDD outweigh the drawbacks? And the way that we did that, we actually asked pairs of questions, one of which would kind of ask about the benefit, and one of which would actually ask about the drawbacks. So we're a little sneaky, because these pairs weren't together in the survey. So for example, with code generation, we asked, is your use of code generation an important aspect of your productivity gains? Does it lead to productivity, basically? But we also asked the flip side of that question, which was, is integrating generated code into your existing projects an issue for you? Okay. And then by comparing the answers to this, you can get some sense of whether the benefits, the first question, outweigh the drawbacks, the second question. So 75% of people told us that they agree or strongly agree with that first statement. So a significant majority of people of our sample who were doing MDD said that it did lead to productivity gains. But did these people also have issues integrating the code? Well, the answer is that no, not really. So this, only 35% of people said that that was an issue. So this thing about, oh, it's going to be so hard to integrate your code is a bit of a myth, it seems. The balance here says that actually, on balance, you'll get productivity increases from code generation. Another interesting issue is that best practice in MDD says that if you're going to make changes, you should make it on the model level. You shouldn't touch the generated code. Once you start touching the generated code, you have to kind of update your model, and you get into kind of synchronization issues between the model and the code, and it all gets horrible very, very quickly. So best practice says always make changes at the modeling level. But the question is, do people actually do that in practice? So again, we asked two questions. Question one, do you mainly make updates on the model rather than the code? And question two, do you spend a lot of time synchronizing the model and the code? So again, the flip side of this. And again, by comparing the answers, we can get some way towards the truth. And what we find is that 70% of people say they do make updates on the model rather than the code. And only 35% of people say that they spend a lot of time synchronizing the model and the code. So it seems, according to this data, that in practice, people do actually follow the MDD principles that have been set out. So that's good news. It means that people listen to evangelists. I suppose that's good. What about flexibility? So there's lots of different arguments about how flexible MDD is as a process. There are people that will say, well, it actually makes you faster at implementing new requirements, because if a new requirement comes along, you just change the model and then you generate everything. It's really easy. On the other hand, you'll say that, no, MDD actually prevents you from being agile in your business, because you have to make a very large upfront investment in terms of training and in terms of tools and things like that. So it actually prevents you from being flexible. So what's the truth? Well, again, 75% of people said it made them faster at implementing new requirements, and only about 32% of people said it prevented them from responding to new business opportunities. So on balance, it seems that MDD does improve flexibility in general. There's an interesting one about training. So some people have told us anecdotally that actually you can reduce your training costs through MDD because it allows you to kind of hire fresh out graduate software engineers that don't know a lot about your business because your business is encoded in the code generator. But then other people say, no, there's a huge amount of extra training that's involved. You have to teach everybody UML and all this kind of stuff. And so the truth here is that the truth is that we don't really know too much here because almost half of the people said that actually it does allow them to take on people with less experience, but a significant majority said that they are required to do extra training. So perhaps if you interpret that, you can say that MDD does increase the amount of cost you have to spend on training. There's something about UML. Again, this survey wasn't just about UML, but I always include this for fun, especially if there's some UML people in the audience, as there have been in the past. Is UML too complex? About half of the people say it is. Is it powerful enough? About half of the people say it is. So it seems that UML is both too complex and not powerful enough. And tooling, this is an interesting one. So there's been a huge industry about providing modeling tools, and some of these tools are very expensive. I remember $6,000 for a license is one kind of ballpark. Which may perhaps lead organizations to try to deploy MDD using kind of cheaper tools and then not getting it right because they don't have the tooling available. Well, about half of the people say the tools are too expensive, and about half of the people say, that organizations are doing it on the cheap. But the real interesting thing about this is the follow-up question, which we asked, which tools do you use? And of 449 respondents, there were over 100 MDD tools that people said they used on a regular basis. Now that suggests to me that despite many years of the tooling market, it's actually not a very mature market. There's no single market leader in terms of this is the tool that everybody uses. There's no silver bullet. There's no one size fits all. People are using lots of different things for lots of different purposes. It comes back to this diversity again. Okay, a quick word about education. We weren't specifically looking for educational issues when we did this study, but stuff came out that we thought was quite interesting. And that is that I believe we may be teaching modeling the wrong way. And there's two reasons for this. If you look at the way that modeling or even software design more generally is taught in universities, it's typically taught in a very top-down way. Software 101, first you do your requirements, then you do your architecture, then you do the design, and then finally you start to do some code, and then you kind of test that. It's still taught in this kind of top-down waterfall model, which students have a lot of trouble with because they're being asked to design a system that they don't really fully understand yet because they haven't had a chance to kind of code it up. If you look at the way that people introduce model-driven development in industry, the people that are most successful, as I've mentioned earlier, actually do it from the ground up. The top-down efforts in organizations don't work. Where it does work is where little groups of developers get together and they're like, oh, let's try this model-driven development thing, and it kind of works, and then another little group gets together and they do the same thing, and then it kind of bubbles up from the ground. Or in other words, what they do is they realize that they are writing the same kind of code again and again and again, and so they start after a while to think about, can I abstract that, and can I write my own little modeling language and my own little generator? So I think there's a big mismatch here between how we teach modeling in universities and how modeling is successfully introduced into industry. When I haven't tried to do this yet, but it does suggest that if we want to teach people modeling or design, we should get them to code first, maybe code multiple versions of the same thing, and then have them think, okay, how would you abstract from that? How would you go one level up from that? So do it from the ground up. The other reason why I think we're teaching modeling the wrong way is because to be successful with this stuff, you need two skills. One is that you need to know how to create modeling languages. You need to know how to meta-model and all that kind of stuff. And the other reason is that you need to be able to write code generators. You need to be able to write, a good optimizing compiler, essentially. But if you look at pretty much any computer science curriculum anywhere in the world, and maybe there are exceptions, but anywhere in the world, we tend to separate these two skill sets. So after perhaps a first year in an undergraduate program where people study a bit of everything, people then kind of tend to specialize. They either go down the kind of hardcore algorithms analysis kind of route, or they go down the kind of softer software engineering requirements route, which means that we end up training people that don't have both of these skills. They either have the hardcore compiler optimization skills or they have the software engineering skills, but they don't have both. But if you want to do MDD effectively, you kind of need both. Okay, so I will finish by giving you a quick run through my top 10 tips for practitioners. If you're a practitioner and you're thinking about adopting MDD or you have adopted MDD, what should you know? Number one, keep your domains tight and narrow. Where you will fail is if you try to formalize a really wide domain like banking, for example. You will spend years trying to do that and not get very far. Where you will succeed is if you've got a very particular problem, a very specific problem that you understand and you can formalize that domain. So if you're, keep your domains as tight and narrow as you possibly can. Number two, don't try to use model-driven development on a domain that you don't understand. And I've done this myself. I've made this mistake myself. But don't go in and say, okay, we're going into the business of social networking now, so let's come up with a modeling language of social networking. Unless you've been working in social networking for 10 years, you won't really understand what the concepts of the domain are, so you won't be able to come up with a good modeling language and a good generator for it. So make sure that you understand your domain well. You must have written lots of applications in that domain before you even start about modeling. Now, this actually may tend to suggest that model-driven development is not good for innovation projects. And this may be one of the reasons, certainly not the only one, why a lot of startups don't use something like model-driven development, because if you're innovating, you don't understand the domain well by definition. Therefore, you're not going to find using MDD very easy. Number three, interesting one, put MDD on the critical path. So often, you introduce a new technology and the organization thinks, oh, we don't really know if this is going to work. So what we'll do, we'll get a pilot together on the side and we'll put a couple of people on it. They can try something, see if that works. Well, it won't work. It will fail, I guarantee it. What you should do is you should introduce it incrementally, yes, not as a big bang, but you should introduce it on an application that is critical to the business, critical to the organization. Why? Because only then will you get the best people to work on it, only then will you get the best resources to work on it, and only then will you have a chance of succeeding. Number four, already said this, MDD works best when driven from the ground up. If you go in one day as a manager and say, all right, everyone, we're going to model today, you're going to have lots of problems. You need to it needs to be a grassroots-driven thing that kind of works from the ground up. Number five, this is the thing about code generation giving you benefits in one part of your organization, but losing benefits in another part of the organization. There are gains from MDD that you can get that can be offset in another part of the organization if you're not very careful, so be careful about that. Number six, don't obsess about code generation. As we've seen, MDD is not principally about code generation, it's about improved quality architecture reuse. Number seven, not everyone can think abstractly, and the jury's still out on this, whether you can take anybody and teach them to model in a good way, or whether some people are just better at working with concrete things. But if you're putting a team together to do MDD, you should understand, which of your people are good at modeling, which are not, and make sure that the people that are not go off and do something else. Number eight, most projects fail at scale up. So even if you're following this kind of ground up way of doing things, which is the right way to do things, that you'll run into issues when you try to scale that up across the organization. Number nine, my personal favorite, match tools and processes to the way that people think, not the other way around. We have a terrible tendency within academia and within industry, I think, to come up with a new idea for a new tool, and then we implement that tool, and then we kind of take it out, and we're like, everybody use my tool, and nobody uses my tool. And often the reason for that, unless we get very lucky, is because we don't understand how the organization works, or we don't understand how the people work. So we're creating something that doesn't match their existing processes. Okay, so what I think we should be doing is to study people first and then create things that will match their processes better. And then finally, number 10, well, okay, I was lying. There's actually only 9 top tips for practitioners. If you do all this, you may, and I say may, find that MDD is your holy grail after all. You may not. If you want to read more about this stuff, there's lots of stuff we've written about this. So we had 2 papers in ICSE in 2011. We had a paper in the Models Educators Symposium that talks about the education part of it. There's a journal article that talks a lot about the data and science of computer programming that's now online and has just come out. Those are all pretty easily accessible. What next? Oh, and by the way, if you want the data, sometimes people ask us for the data because they want to do their own analyses on it. So we've made the data, at least from the survey, publicly available. So that's available if you want it. What next? Well, this effort started as a phase 2 thing. Phase 1 was always about understanding existing modeling practices. Phase 2 was about improving model-driven practices. And the way to do that, I thought, was to understand how people and organizations work first, and then to try and come up with new ways, new techniques, new methods that actually matched that. So phase 1's over, although we're still doing some of that. And we're now starting to think about phase 2, and we're actively partnering with companies as part of this. In fact, we just wrote a very large grant proposal where we're trying to build a kind of global network of people who are trying to understand better how software designers work and trying to provide different, more radical, better ways of kind of producing design tools for designers. And that's what we're doing. So if you're interested in that, just talk to me. I think I'll stop there.
We have time for about one question.
Yeah.
If it's a short one, maybe we get a second one in. Anyone have a question?
Silly question.
Silly question.
Yeah.
I have a silly answer.
I think I just recently started understanding the practices of extreme programming.
Yeah.
So I wanted to understand if MDD is or can be an attribute of extreme programming.
Good question. That's a different talk, but I'll give you the highlight. Basically, historically, people have thought of these as, you know, opposite ends of the spectrum, and there's been lots of fights between the MDD people and the Agile people. We've recently finished a study with 3 companies in Sweden who are introducing Agile practices at the same time as doing model-driven development. And what we found is that they're not at the opposite ends of the spectrum at all. They actually can coexist very nicely in the middle. I haven't done enough analysis of the data to say anything deep about it yet, but there's lots of interesting stuff in the data that we plan to write about. And so certainly they can work together, yeah, despite what people might think.
Any example of failure of MDD? Any kind of field where didn't meet the...
Yes. There's another talk again, what I call the good, the bad, and the ugly. I'll just skip through it extremely quickly. The good is the company that succeeded. I won't tell you why. The bad ass is a company that really succeeded. They really, really succeeded. But there is a company in there that was the ugly that didn't succeed. And the reason they didn't succeed was a combination of these things. They were trying to apply it in a domain that they didn't really understand. They were seeing it very much as a top-down effort. They weren't doing it for any business reason. It was just somebody had an idea, let's do it. But it wasn't part of their business plan. And there was a lack. It introduced lots of control issues with the developers. They had a lot of issues with the tooling that meant that the developers lost control of the whole process. So yeah, it's harder to get to the failure examples because by definition, they're off the radar. They've gone somewhere else. But we do have some cases where it's failed. Yeah.
Thank you so much, John. Let's thank our speaker.
Thank you.